All right, you guys, more examples to go over here. I know these videos are nice and short and sweet, but I hope it gives you the general idea of what you need to do. Now we're going to be working specifically with the diagonals of a parallelogram. So the first thing we're going to be looking for is now we're going to be solving for and looking for the value of r. So r is right here and right here. So we're actually going to be applying some simple tasks here, okay? So we may be doing multiple things here just on this one screen because it's going to be, we're going to probably be solving for S and also for T. This one seems to be the simplest one first. Now notice that R is up here and it's the length of this whole side here. So we know from what we were talking about that it's equal to opposite side. So this side over here is what we're talking about now. So if that's the case, we're going to take 4r and 18 and we're going to go over here and we're going to go 4r equals 18. That means in order to solve for r, we're going to divide both sides by 4. That means r is going to be equal to, and let's see if I have my calculator here. I'm going to pull it out. Turn it on and I'm going to go 18 divided by 4 equals 4.5. So we know that r equals to 4.5. So there's our first answer. Okay. The next thing we're going to solve for and on our screen is that we want to solve for S now. So I'm going to change colors here. Let's go red. And now we're looking for S. So where's S located at? So we know we can see it. It's right up here. Okay. And we're talking about this part of this diagonal right here. We also see that there's an S in here too. Okay. And that means we're talking about this side as well. And what do we know about the diagonals? So this is our diagonals. We know that this side is going to be equal to this side. So basically what we're going to do is we're going to take 8s, okay, and we're going to set it equal to the other side, which is going to be 7s plus 3, okay? Now it looks like almost like it looks like I said 85 here, but I apologize on that part. So what we want to do is we want to go ahead and I'm going to subtract 7s from both sides. That wasn't a very good 7. Anyways, these are going to cross off, okay? And then we're going to get s or 1s, whatever you want, so it equals, and this makes it really easy, so we get an answer of 3. So we have our answer of s equaling 3. So we're applying what we just learned here, okay? So the next step we want to do is we're going to solve for T. So let's change colors here. Let's go blue. Well, blue's already out there, so let's go purple. Okay, so where's that at? So where is T located? It's right up here. Okay, and we're talking about this angle specifically right here. Okay, all right, now this goes back to first semester scenarios where we have to apply what we've learned before, and the fact that we can also say that this angle can be congruent to this angle right here. Does anybody remember why we can say that those two are equal to each other? The answer is because we have parallel lines, okay? And then we call this line right here, this diagonal, a transversal, if that word reminds you of something. And then we have a transversal. That means that these angles are inside the parallel line. So that means these are alternate interior angles. Therefore, they are equal to each other. So what we're going to do is we're going to take 2t and we're going to set it equal to 18. Okay? Any questions on that part? Okay? So any question about that? Makes it really easy to do that. So then all we have to do is divide both sides by 2. These cancel out. That gives me t now equals 9. So we solved all the variables that we needed for this whole thing here. Okay, I hope you guys got that and understand where we're going from on that. Okay, and we had to apply something that we had learned from previous semester. Anyways, let me know if you have any questions. We can chat about it in class if we need to.